Hello, everybody. My Chinese is not up to par, so I need to speak in English. So as introduced, today I want to show you how one of our new services that just came out last year, called AWS Lambda, can be used to basically build a JavaScript interface, have a Node.js in the backend, but do all that without running a single server. Now, before I get started, let's start with the basics first. If you run a web application, what is it what you generally expect from any web application that you run these days? Well, first of all, you always expect it to be available. You want high availability. You want your application to be able to scale to potentially millions or billions of users from day one without changing anything around your application. You want to have a predictable responsiveness, because a user interface these days, if it's not responsive, then your users will complain. They will think that's something wrong with your web application. And one other important element is fault tolerance. You want your application to be fault tolerant. If something breaks, it should heal itself. Your end users should never notice that anything goes wrong. Now, how could you achieve that? Well, you could go ahead and say, well, how about I build all my data center facilities across the world? I build auto-scalable databases. I build an auto-scalable server infrastructure with servers that scale, where I can add to it. I load balance across those servers, etc. There's a lot of things that I would need to do to actually make that happen. And I call that heavy lifting. This would be like with your little truckload, you bring in servers and servers and servers and servers. And that is not what we want to do. We're web developers, and we want to build an application. What we don't want to do is focus on building servers. So before jumping into AWS Lambda, I wanted to give an overview of what Amazon Web Services actually is. So Amazon Web Services provides, as it says, web services across the world. That is specifically across 11 regions around the world, with the newest one being launched in Beijing and Frankfurt in Germany. Now, within those regions, we have a concept called availability zones. Now, this is a very interesting one because we actually leverage that for the web application that we're building. An availability zone is a cluster of data center. In every region, we always have at least 2 availability zones, so at least 2 of those clusters of data centers. However, they are connected to different power grids and different network connectivity. That means if you build an application that spans across availability zones, you can tolerate a complete power loss. A complete data center goes down, but your application is still online. And this is important for you. Beyond that, we also have 53 edge locations across the world, including one here in Taipei, in Hong Kong, in Manila, here in the area, all across the world, that actually allows you to deliver your web application faster with an accelerated network performance to your end user. And I'm going to show a demo later where we see all this in action. And we continue to keep on expanding into new regions, new edge locations across the world. Now, when I say web services, what do I mean with web services? Well, we touched upon the green bar here, which is the infrastructure, our data center facilities and edge locations that we build across the world. But what do we build on top of that? Well, we build a variety of core services and platform services on top of that that you can consume. And one important, interesting element is that everything is pay as you go. So it's like electricity, like light. If I switch it on, I pay for it. If I switch it off, I stop paying for it. All the services that you see in AWS are exactly that model, utility. And we have a layer of security, so if you want to build secure web applications, no problem. All kinds of auditing and access control capabilities, monitoring capabilities, services that monitor your application, maintain it, encryption capabilities. And then we have core services, and we're going to touch on these today in the demo I'm going to use. Lambda, which actually falls under the compute core service. We also have storage and database services, and obviously networking services. More interestingly, though, is also that there are services around platforms. So you can have complete managed analytics services if you want to manage a Hadoop cluster, manage data warehouse to understand your users better, or if you want to have mobile analytics, we have services around that you can consume. All the way up to the application layer where we talk about virtual desktops or application delivery or email services. Now, important to note is the bar here on the right side. whatever you see here, and I didn't write down service names, but all the services that fall under these categories can be addressed via an API or an SDK. We have software development kits for all kinds of languages: Python, Ruby, PHP, JavaScript, Node.js, .NET, etc. So all of this, what you consume, can be done programmatically. And I'm going to show you in a bit on how we do that. However, today's talk is specifically around AWS Lambda. So what is AWS Lambda? So AWS Lambda is a service that allows you to put your code into AWS. Right now it would be JavaScript code, so think in the lines of what Node.js would look like. And we maintain that code and we fully manage it. We then deliver it throughout the region, highly available. So it scales automatically. You do not need to worry what that means. Do I need a server? What operating system? What data center? No, you just upload the code and we deploy it within a region across multiple availability zones. It automatically scales. So it can scale to potentially millions, billions of execution calls. From your perspective, you're only charged against every 100 millisecond execution time. And you get actually 2 million seconds for free every month. So from your perspective, it's you create code and you only pay for whenever somebody is using that code. You do not need to worry about, is it highly available? You do not need to worry about, is it fault tolerant? You do not need to worry about who is maintaining those servers. That is Amazon's problem. Your problem is bring in that code. So specifically, what is AWS Lambda? We call it Lambda Functions. So you create a function and you can put in your code into that function, just like you would do in an Excel sheet, right? You create a little cell and you create a function attached to it, and then it updates it. Important to note, this code is stateless. So you cannot store state in that code. And I get to that in a bit, what we can do about that. The good news, though, is that you can invoke that function from something like the JavaScript SDK, from something like the mobile SDK. So if you create an Android application or an iOS version or any kind of desktop application, browser application, you can invoke that function. More interestingly, you can also have that function invoked based on an event trigger in your environment. So if you consume some of the other AWS services, you can say, I create a new object in my object store. And whenever that happens, trigger a function. Whenever somebody writes something to my database, trigger that function. When somebody sends a new message to my notification service or to my real-time data processing service, trigger that function. Today, although, we're going to focus on invoking that function from the browser. So that would look like this. We use the AWS JavaScript SDK. We load it in via loading it in here in the browser. We then create an AWS Lambda object. And when we create that object, we can start invoking that function in the backend and processing the result whenever it's being processed in the cloud and sent the result back. Now, you're going to tell me, this is great, so I can process code in the cloud from my browser, but I need to get this into the browser. And you said, well, no servers, right? So how do we get the SDK into the browser? How do we get this code into the browser? I want to get that JavaScript inside. Well, there are two other services within Amazon Web Services that can be of interest. The first one is called Amazon S3. It stands for Simple Storage Service, and it's a highly available object store. Anybody knows Dropbox in here? Dropbox.com? Few people. So Dropbox.com actually built their service on top of Amazon S3. Right? They create a client that uses Amazon S3 in the backend. We're very proud of that. They're publicly referenceable for that. Now, this storage is designed for extreme durability, 11 nines of annual data durability. What that specifically means, if you have 10,000 objects, you would lose 1 in 100 million years. So you don't lose data. But the cool thing is, it also offers HTTP and HTTPS endpoint connectivity to any object you're storing inside that bucket. So what are we going to do? Well, we're going to put our HTML, our CSS, our JavaScript files into that bucket, and we now have a web server to serve it up. without actually maintaining a web server. Now, however, this S3 bucket sits in a region, so the closest would be Tokyo or Singapore from here, from AWS perspective. So you're going to say, for type A, I want to deliver it fairly quickly. So what I'm going to do is I use Amazon CloudFront, which is our content delivery network, which leverages 53 edge locations across the world, including the one in Taipei, to actually deliver that content to the end user. So if I actually access it, when I show you the demo later, it comes from an edge location in Taipei. The actual content sits in an S3 bucket. I do not need to maintain any server to get that done. So the JavaScript file, the HTML files, they flow from my bucket to CloudFront to the browser. Now, I said Lambda is stateless, right? So you're going to ask me, well, it's great. We get JavaScript and HTML. We get that to the browser, highly available, durable, without running a server. We can execute code in the backend with AWS Lambda, but how about storing data, right? We need some form of database, but we don't want to maintain a database. So what we're going to use is Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL database. Important, it's a service, which means that you create a table, and then you can start reading and writing as much information from that table as you want. You do not need to worry what that means in terms of server, in terms of storage, in terms of scalability. You do not need to worry about, is it durable? Do I need to do backups? No, because this thing is automatically replicated across 3 different facilities. It scales to potentially any kind of amount of storage, any amount of records, and more interestingly, any amount of throughput. So you can start off and say, I have 1 write per second to that database, and a minute later you want to have 1,000,000 writes per second, no problem. DynamoDB does that. If a minute later you decide, no, I don't need that, 10 writes per second is sufficient, you can scale it back. You're only charged per throughput, per write, per read on the database, not on the underlying storage level. So, if we put all this together, we would get an architecture that would look like this. And I want to show a demo of this. So specifically, we're going to store an application in an HTML and JavaScript file that we put in an S3 bucket. We then deliver that through our content delivery network, so that it's a fast delivery to the end user, to the browser. The browser itself is now using the JavaScript SDK to talk to the Amazon Lambda service. The Amazon Lambda service is able to execute code, right? And that code could, for example, write something to the Amazon DynamoDB, to the NoSQL database service. At the same time, it could do something else, such as use our Amazon Simple Notification service to send out a mobile push notification, to send out an email, to trigger some other notification. And this allows us to say, I built an application that is highly available, right? Even if a data center fails, this application remains online. It's scalable. You start with 0, and you can go to millions of users without changing anything here. It's fully managed, so you do not need to log in into any of the servers at any point in time, pull any log files, do anything. No, it's fully managed, and it's completely fault tolerant. Right? It automatically fails over. Amazon CloudFront uses 53 edge locations across the world. You want to bring this down? You need to bring down Amazon on 53 locations across the world. And you get all that out of the box. Now, this was a very salesy talk. What I rather want to do is show you a demo to see how that looks like in real life. All right, let me switch over to this. There we go. All right, so what you can see here is actually the Amazon Web Services console and their variety of services. Let me make this a little bit bigger. So what we're going to touch on today is we're going to use S3 to store our HTML, CSS, and JavaScript files. We're going to deliver them through the CloudFront service. We're then going to use the JavaScript SDK to run a Lambda function that will write information into DynamoDB and at the same time use our simple notification service to send me an email. So let's start with the first things. So I actually created a little index file. So this is my index.html with a little JavaScript, and I get to that in a bit. What I've done, I actually created an S3 bucket called Olivier K demos here, and I uploaded all these files into it. So it's as simple as clicking this upload button, and the files go up. Interestingly, it has a static website hosting endpoint if I enable it, so I can look at those files. What I then did is I went to CloudFront and I said, let's just reload this. Let's hope the connectivity works. There we go. I created a CloudFront distribution and I pointed it to this Amazon S3 bucket. Now what this will give me is an endpoint here that I can now load. I'm going to do that. And this comes from a CloudFront edge. So now I loaded in my index.html and I loaded in my JavaScript file. Now if I look at that code, let's have a look at it. Here's my index.html file. So I loaded in jQuery. I'm using jQuery. Don't judge me, please. And I used the AWS SD JavaScript SDK. Bit of mix mesh here to make it look nice. I use Bootstrap because I'm lazy, so it looks good. And here at the bottom, I also included my Lambda Demo Js. Okay, this is some code that I wrote. So let's have a look at this. So I actually create a Lambda object here. Whoops, there you go. A Lambda object here. And then I create a trigger on two buttons on the page. So one is this load button, which is the one that you see here. And then the other one would be the post button, which is the one that you see here. And what I did onto those buttons, very simple. I say, well, I call a Lambda function called getAllPosts on the load button, and I call a function called createNewPost on the post button. And I then use Lambda invoke to invoke that function and render the results that I'm seeing. Now, let's have a look at the back end. So at the back end, I'm just going to reload this very quickly. You could click into Lambda. You can choose the region. So here I chose Oregon. There would be other regions that I could also choose. And I can see my functions. I can see the code size that they have, and I can attribute them some components like memory that I think that function requires. It's fully managed, so the only thing that you need to do is actually input the code. So let's have a look at the getAllPost function first. So you see it's a very simple JavaScript function that I created here. I said load in my JavaScript AWS SDK, use this region, and then I create a new object called DynamoDB. So this is when I start talking to the DynamoDB service. I tell him from which table I want to load, and then I'm telling him please load the one with topic date index called Lambda Demo. I query that database, and if it's successful, I create little comment objects here, and I send them back to the invoker of the function. So this would be the browser in this regard. So this would be the getAllPost function. Let's have a quick look at my DynamoDB service. So if I click on DynamoDB, you see that I actually created a Lambda Demo Post table earlier. And if I would explore that table, let me just reload this because this is all in the browser cache. So you see that's an actual demo. No smoke and mirrors. There you go. If I open this up, you'll see I actually have some entries here. This is quite interesting. It's a NoSQL database, so there's no schema attached to this, right? The only thing that I need to say is what is my hash key, just like any kind of other NoSQL database would work. So whatever my JavaScript or my Lambda function would try to write into this DynamoDB, if it contains additional attributes, they would just be added to it. So let's try this. Let's go back to my interface here. I'm just going to reload this. And what I'm going to do is I'm going to show you here the network. So if I would try to reload all this, there we go. You see this is all coming from CloudFront. Right, this didn't come from any of your web servers. By the way, if you think this is an ugly URL name, I agree with you, it is. So you can use your own domain name, of course, if you want to put your own domain name, and that's what you should do. You can use that. But point being is, this is all coming from the CloudFront, the Content Delivery Network service. Now, what I'm going to do is I'm going to clear this, because what I'm going to do next is hit that Load Comments button. This will trigger a jQuery event, right? The jQuery event that I created that said if I click that button, I invoke a function called getAllPosts to the Lambda service. I showed you that Lambda function. It creates a DynamoDB table. It queries that table, creates comment objects, and returns them. So let's try that. If I would click it, you see down here, it's actually invoking Lambda US Vest. It is invoking that service. And it comes back with response. And there we go. We now got our comments from the DynamoDB table. Now you say this is great. How about the post function? And before I do that, I just open up my Gmail here. There you go. That's always when you show a demo, you already has something inside. So I got an empty email box. Switch that over. So we're going to use a different function here. I'm not going to use the getAllPost function. Remember when I set post button? I invoke a different function. In this scenario, it was to create new post function. Same thing applies. Very simple function here. I say create a DynamoDB object, create a simple notification service, SNS object. Load in what the browser is sending me, create an item for it, and then put that item into the database. If there's any error, alert me. If not, then go ahead and publish to a notification topic. That is the notification topic to which I have my email registered. That could also be a mobile application. That could be any kind of endpoint that you want to notify. If that's successful, well then return to the browser that it was success. Right, cool. So let's try this. So if I would like to post this comment, and let's make this a little bit more fun. Say, ni hao. Well then, well, conference. It's Unicode, so that's why I'm okay to do this. So Chinese should work. I haven't tried this, so let's see. I'm posting it, so you can see here again, it's invoking this directly from the JavaScript SDK through the Lambda function in AWS. It didn't go to any server. And it did work, and there we go. It actually loaded it in. It did another invocation of loading those new comments, and the comment was successfully posted. This message, by the way, is coming from the Lambda function. You can see that down here. Oops, sorry, wrong window. You can see that down here. I actually sent this back as a JSON object, and then I just display that JSON object in the browser. But that Lambda function had one other thing, which was it also published to a simple notification service topic, which is attached currently to my email. So if I go to my email here, I actually see, great. Down here, that was another test message earlier. Ni hao modern web conference. I got an email straight out of the box. Now what we created, this is pretty cool. What we created is an application that works completely without any browser. If I would look at my DynamoDB table here, I scan it, you see here, there you go. I think somebody just injected something for me here. It did go through. There you go. Try your SQL injections. They won't work. Because there is no SQL database behind. This is all a complete NoSQL managed database service. So the beauty of this, and this is interesting, let's see if we actually manage to, probably should show this up. Probably, no it doesn't. Okay, it's stripping the HTML. Thank you, jQuery. I think the actual reason is because the Lambda function sends it back as an object, and so it strips out those tags. But good try. Thank you. But basically, I'm going to switch back to this. Basically, what we created is now a fully scalable web application. It all resides in an S3 bucket. We send it out through CloudFront. So any user, regardless where he sits in the world, he gets it from a edge location close by. We can store data in a scalable database. that we only pay for exactly what we use, and we invoke functions from the browser straight to Lambda, so that looks like a Node.js server with the benefit that you do not need to manage it at all, right? And it scales to any kind of capacity. It's fault tolerant and highly durable. Now with that, I want to thank you all very much for this little demo time, and I hope this was insightful. I'm around here. If any questions are, I can take them now. Otherwise, we also got an AWS booth up there. If you want to talk about some of the AWS services, happy to assist you on what could be useful for your web projects that you're running. And I would appreciate it, my colleague gave you a few forms earlier. If you could fill those out, just give me a bit of feedback. Is this something useful or not? That would be greatly appreciated. Thank you very much.